Imagine zooming out from Earth, past the Moon, beyond the planets, leaving the Milky Way behind. As the universe unfolds around us, something unexpected appears. Galaxies aren't scattered randomly across space. They form enormous filaments stretching across hundreds of millions of light years. Together, these filaments weave an immense network astronomers call the cosmic web. It's a structure so vast that it forms the hidden skeleton of the entire universe. But here's the mystery that keeps scientists awake at night. Why would the universe organize itself into something like a gigantic cosmic web? How did galaxies end up lining up along these enormous filaments? Why do vast empty voids exist between them? And how could tiny ripples in the early universe grow into structures spanning billions of light years? Tonight, we're going on a journey across the largest structure humanity has ever discovered, from the smallest particles to the vast architecture of the cosmos itself. And by the end of this journey, you may never look at the universe the same way again. Out there, beyond the quiet glow of our night sky, the universe hides a strange pattern. When astronomers map the positions of galaxies, they notice something surprising. Galaxies aren't scattered randomly like grains of sand thrown across a floor. Instead, they seem to follow enormous invisible pathways stretching across space. Imagine zooming far beyond our Milky Way, past thousands, then millions of galaxies. From that cosmic vantage point, something remarkable begins to appear. Galaxies gather along long luminous threads, forming intersections and branches. The universe starts to look less like chaos and more like an enormous cosmic web. These threads span unimaginable distances, hundreds of millions of light years long. Clusters of galaxies form bright knots where several of these filaments meet. Between them lie vast dark regions where almost nothing exists. It's as if the universe has bones, an immense skeleton made of galaxies. But here's where the mystery deepens. The laws of physics never said galaxies had to arrange themselves this way. So why would matter across the universe settle into such a vast, interconnected structure? Why would the cosmos weave itself into something resembling a giant three-dimensional web? To answer that question, astronomers first had to confirm something extraordinary. They needed proof that this cosmic web wasn't just an illusion of observation. And as telescopes began mapping the sky in greater detail, a hidden pattern slowly emerged. A pattern so vast that it reshaped how humanity sees the structure of the universe. As telescopes grew more powerful, astronomers began mapping the universe in unprecedented detail. Instead of observing a few galaxies at a time, they started surveying millions across the sky. Each galaxy became a tiny point on an enormous cosmic map, and slowly, a hidden pattern began to reveal itself. When these maps were assembled, the results were astonishing. Galaxies weren't evenly spread across space like sprinkles on a cake. Instead, they traced enormous lines and arcs stretching across the universe. These structures looked like glowing strands woven through the darkness. Between these strands were regions almost completely empty. These vast expanses are known as cosmic voids, and they can span hundreds of millions of light years. If galaxies are the lights of the universe, then voids are its dark oceans. Together, they form a pattern that resembles a colossal three-dimensional spiderweb. Large sky surveys, such as those that scan huge portions of the heavens, reveal this structure clearly. When astronomers convert their data into visual maps, galaxies line up along thin filaments. Where several filaments intersect, dense clusters of galaxies appear. These intersections become the great cities of the cosmic landscape. The more scientists map the universe, the clearer this web becomes. It stretches across billions of light years, connecting galaxies across unimaginable distances. But this discovery raises an even deeper question. How could such an enormous structure begin from the tiniest ingredients in the universe? To understand how the cosmic web formed, scientists had to travel backward in scale, far smaller than galaxies. They had to look at the tiniest ingredients of the universe itself, because every galaxy, every star, and every planet ultimately begins with particles. Tiny building blocks like protons, electrons, and mysterious particles known as dark matter. In the earliest moments of the universe, matter wasn't arranged into stars or galaxies yet. Instead, space was filled with an almost perfectly smooth ocean of particles. But almost is the key word here. Hidden within that smoothness were tiny ripples in density, subtle variations in how matter was distributed. These fluctuations were incredibly small, Imagine the surface of a calm lake with barely visible ripples spreading across it. Some areas contain just a tiny bit more matter than their surroundings, and those slightly denser regions would become extremely important later. Gravity has a fascinating habit. It amplifies even the smallest differences. Just like a snowball rolling downhill gathers more snow as it moves, a region with a little more matter pulls in nearby material. Slowly, steadily, that small imbalance begins to grow. Those microscopic variations in the early universe became the seeds of everything that followed. Over time, gravity turned those tiny irregularities into enormous structures, from particles to clouds of gas, from clouds to galaxies. But before the universe could build structures on such a vast scale, the same forces were already shaping smaller systems closer to home. To see how structure forms in the universe, scientists sometimes start closer to home. Right here, within planetary systems, the same basic principles are quietly at work. Gravity, the invisible architect of the cosmos, organizes matter wherever it can. And the story of planet formation offers a perfect miniature version of this process. Around young stars, vast rotating disks of gas and dust swirl through space. At first, the material is thin and spread out, like flour floating in the air. But gravity begins pulling particles together into tiny clumps. Slowly, those clumps grow larger, attracting more material as they spin. It's a bit like watching an ice skater pull their arms inward during a spin. As the skater gathers mass closer to the center, the rotation speeds up. In a similar way, dust and gas spiral inward and gather into growing bodies. These clumps eventually become asteroids, moons, and entire planets. Over millions of years, collisions and gravitational attraction shape these forming worlds. Small rocks merge into larger ones, and larger ones become planetary embryos. Eventually, full-sized planets emerge, orbiting their star in an organized system. What began as scattered dust becomes a structured family of worlds. This same principle, matter gathering under gravity, scales far beyond planetary systems. The forces shaping planets also operate across galaxies and clusters of galaxies. The difference is simply the scale, stretching from millions to billions of light years. To understand how scientists study these colossal patterns, we must look at the tools they use to map the universe itself. To uncover the structure of the cosmic web, astronomers had to do something extraordinary. They needed to chart the positions of galaxies across enormous regions of space. Not hundreds or thousands of galaxies, but millions of them, each one acting like a glowing marker in the vast darkness of the universe. Large astronomical surveys became the key to this discovery. Powerful telescopes scan huge portions of the sky, measuring where galaxies are located. They also determine how far away those galaxies are from Earth. With that information, scientists can build three-dimensional maps of the universe. When these maps are visualized, the universe suddenly comes alive with structure. Galaxies line up along immense filaments that stretch across space like luminous highways. Between them lie enormous empty bubbles, cosmic voids where very few galaxies exist. The result looks astonishingly like a giant sponge or web floating through space. But telescopes alone cannot tell the entire story. To understand how these structures formed, scientists turn to another powerful tool. Supercomputers simulate the universe itself, recreating billions of years of cosmic evolution. Inside these digital universes, gravity slowly sculpts matter into the same web-like pattern. Watching these simulations unfold is like seeing time run in fast forward. Tiny fluctuations grow, matter streams along invisible pathways, and filaments emerge. The virtual universe begins to resemble the real one astronomers observe in the sky. Which leads to a deeper question. What fundamental force shapes this enormous architecture? At the heart of the cosmic web lies a simple but powerful force: gravity, the same pull that keeps our feet on Earth and the Moon in orbit. Across the universe, gravity quietly shapes the movement of matter, and over billions of years it becomes the master sculptor of cosmic structure. Imagine placing a slightly heavier ball on a stretched rubber sheet. The sheet bends inward, and smaller objects roll toward that depression. In the universe, regions with a little more matter create deeper gravitational wells. Nearby particles begin drifting toward those regions, pulled by gravity's steady tug. As matter flows inward, those dense regions grow even stronger. More material falls in, deepening the gravitational pull further. It's a cosmic version of a snowball rolling downhill. gathering more snow as it goes. What started as a tiny difference slowly becomes a massive structure. Meanwhile, areas with less matter begin to lose material. As surrounding regions pull matter away, these zones become emptier and emptier. Over time, they expand into enormous cosmic voids. The universe naturally separates into dense filaments and vast empty bubbles. Through this process, gravity stretches matter into long, interconnected strands. These strands link clusters of galaxies across unimaginable distances. The result is the vast cosmic web astronomers observe today. But inside those galaxies forming along the filaments, another story of creation was quietly unfolding. Along the immense filaments of the cosmic web, galaxies slowly began to take shape. Inside these galaxies, vast clouds of gas drifted through interstellar space. Gravity once again took the lead, pulling these clouds inward. Over time, the clouds collapsed and ignited the birth of new stars. Within these collapsing clouds, swirling disks of gas and dust formed around young stars. These disks looked a bit like giant spinning pancakes of cosmic material. Particles inside them collided, stuck together, and slowly grew larger. Tiny grains of dust eventually became rocks, and rocks became the seeds of planets. The process wasn't smooth or gentle. It was chaotic and energetic. Imagine countless pieces of debris racing around a star like cars in a cosmic traffic jam. Collisions merged some pieces together while others shattered apart. Yet over millions of years, gravity gradually organized the chaos. Eventually, stable planetary systems emerged from the swirling disks. Planets settled into regular orbits around their stars, much like the planets in our solar system. Asteroids and comets remained as leftover fragments from this cosmic construction process. From the outside, it might look orderly, but the journey there was anything but simple. Our own solar system formed through this very process about 4.6 billion years ago. A cloud of gas inside the Milky Way collapsed and gave birth to the Sun and its planets. But that cloud existed within a galaxy shaped by the larger cosmic web, which means the grand structure of the universe quietly influenced the conditions that eventually led to Earth itself. It might seem that the cosmic web is far too distant to matter to us. After all, its filaments stretch across hundreds of millions of light years. But in reality, this vast structure quietly shaped the conditions that allowed Earth to exist. In a way, our planet is a tiny consequence of that enormous cosmic architecture. Galaxies formed along the filaments of the cosmic web where matter gathered most strongly. Inside those galaxies, generations of stars were born and eventually died. When massive stars exploded as supernovae, they forged heavy elements. Elements like carbon, oxygen, iron, and silicon, the very ingredients of planets and life. Without these stellar factories, the universe would contain mostly hydrogen and helium. There would be no rocky worlds, no oceans, no atmosphere rich with complex chemistry. Earth itself is built from the recycled ashes of ancient stars, stars that formed within galaxies guided by the cosmic web. Even our sun is part of this long chain of cosmic events. The cloud that formed our solar system contained material from earlier stellar explosions. Those explosions were made possible by the formation of galaxies in dense regions of the universe. And those regions exist because of the enormous filaments of the cosmic web. So the next time someone looks up at the night sky, they're seeing more than scattered stars. They're glimpsing the products of a vast cosmic structure that shaped the universe over billions of years, from giant filaments to galaxies, from stars to planets. But to fully understand this architecture, we must zoom out again, to the scale of galaxies themselves. When astronomers zoom out to the scale of galaxies, the cosmic web becomes even more dramatic. Galaxies rarely exist alone in the universe. Instead, they tend to gather along the long filaments of the cosmic web. These filaments act like enormous gravitational highways guiding matter through space. Along these strands, galaxies travel slowly under the influence of gravity. Over billions of years, they drift toward regions where multiple filaments intersect. These intersections become crowded cosmic hubs, places where hundreds or even thousands of galaxies gather together. These massive gatherings are known as galaxy clusters. They are some of the largest gravitationally bound structures in the universe. Inside them, galaxies orbit each other in complex cosmic dances. Gas clouds collide, stars form, and sometimes entire galaxies merge. Between these clusters stretch the long filaments connecting them together. Imagine a vast network of rivers flowing toward deep cosmic lakes. Matter streams along these filaments, feeding the growth of galaxy clusters. It's a slow but relentless flow that continues even today. When astronomers map these structures across billions of light years, a pattern becomes undeniable. The universe looks less like scattered islands and more like a gigantic interconnected network. But this raises a profound question. Where did this enormous structure first come from in the earliest moments of the universe? To uncover the origin of the cosmic web, scientists had to travel back in time, almost to the beginning of everything. The story starts shortly after the Big Bang, when the universe was incredibly young. At that time, space was filled with a hot, dense sea of particles and radiation. Nothing resembling galaxies or stars existed yet, only a nearly uniform cosmic fog. But even in that early universe, tiny imperfections were already present. Some regions contained just a little more matter than others. The differences were incredibly small, almost like faint ripples across the surface of a calm ocean. Yet those subtle ripples would eventually shape the largest structures in the universe. Astronomers can still see traces of those early fluctuations today. They appear in the faint afterglow of the cosmic microwave background, the ancient light left from the early universe. Sensitive satellites have mapped this radiation across the entire sky. The patterns within it reveal tiny temperature variations, evidence of those primordial density differences. Over billions of years, gravity slowly amplified those early ripples. Regions with slightly more matter pulled in surrounding material. Matter began flowing along invisible pathways, gradually forming long cosmic filaments. Meanwhile, less dense regions expanded into the enormous voids we observe today. From those tiny early fluctuations, the universe built a colossal network of structure. Filaments grew, clusters formed, and galaxies assembled along the cosmic web. What began as nearly imperceptible ripples became the vast architecture of the cosmos. And within that immense structure, one small species eventually began asking how it all came to be. When astronomers step back and look at the universe as a whole, a hidden architecture emerges. Across billions of light years, galaxies trace an immense network of filaments and clusters. This structure forms something like a cosmic skeleton stretching through space. The cosmic web reveals that the universe is not random chaos, but an organized tapestry. Along these vast filaments, galaxies glow like distant lanterns in the dark. At their intersections lie enormous galaxy clusters, cosmic cities filled with hundreds of galaxies. Between them stretch vast voids where almost nothing exists. The universe becomes a landscape of structure, balance, and extraordinary scale. And somewhere within this colossal web sits a modest spiral galaxy. Inside that galaxy, on the quiet edge of one of its arms, orbits a small blue planet. From the surface of that planet, a curious species has begun to map the cosmos. Humanity has slowly started to uncover the universe's hidden architecture. What's remarkable is how the smallest ripples in the early universe led to this immense structure. Tiny fluctuations in matter eventually shaped galaxies, stars, and planetary systems. Those processes ultimately allowed life and consciousness to emerge. In a sense, the cosmic web helped create the conditions for observers within it. So when we look at the night sky, we're not just seeing distant points of light. We're glimpsing pieces of a vast interconnected structure spanning the universe. And within that structure, humanity has begun asking one of the deepest questions of all. Why does the universe have a structure? And what else might it still be hiding?